Okay, we've been talking about opportunity costs and trade-offs and things like that, and there are a million different possibilities in terms of what we can produce, what we can buy, all of those different things. A production possibility curve is just another tool that we're going to use to evaluate opportunity costs because we know that scarcity exists. Every person, business, government has to decide how much of their scarce resources they're going to use on what. How much are we going to produce if we're a business, all of those things. So a production possibility curve, what it does, instead of looking at the limitless trade-offs to evaluate what the opportunity cost is, we're going to eliminate that, and we're going to limit all of our choices in our economy down to two choices. A term I've used before in other notes is this idea of guns and butter. And so when we start actually doing these, we're going to look at guns and butter. But there are different combinations you can use. We can use resources to produce capital goods over consumer goods, guns and butter, like I said. But regardless of what it is, everything we're going to narrow down to only producing two things in our economy. So we have a few assumptions we're going to be dealing with when we're looking at a production possibility curve. One of the assumptions is that in our economy, let's say the United States, that one of the assumptions is that all of the resources that we have available to us are all going to be efficiently and fully used. So we're going to use every human resource, every natural resource, and every capital resource in our economy. Another assumption is that all technologies are efficiently used. So every bit of technology that we have available, we are going to be using it. And then the final assumption is that all of these resources and technologies are fixed. That when everyone's working and we're using all of the technology and all of our natural resources, we have nothing else available to us. And so we're looking at a picture here of a production possibility curve. And we have three different areas that we're going to look at. We're going to look at outside the curve, on the curve, and then actually inside the curve. So the first thing we're going to look at is actually outside the curve. Because when we are looking at producing at our fullest potential and using all of our resources, we're actually producing on the curve, which means anything outside of this curve is an impossibility. We don't have any more resources. On the curve, we're using all of our human resources, all of our natural resources, and all of our capital resources, including technology, so that there is no combination of product A and product B that we could produce because we don't have the humans or the capital or the natural resource available to us. Inside the curve at point X, this is said to be inefficiently using our resources, underutilizing our resources. You'll see those two terms used. And so once again, on the curve, we're using all of our resources efficiently. So if this were the level of product A, we could actually come out and produce at this level of B, but for whatever reason, we've decided that we are going to produce this many good of product A and this many of product B. And a reason that we would produce this, even though we know that we have the capacity to produce all the way out to the curve, is because of demand. During times of recession, during times of unemployment, we don't have the demand, so there's no reason just because we can produce at this level that we would. We kind of looked at one of the problems that created the stock market crash and the Great Depression was the fact that they were producing at a level greater than what people actually wanted. So we're only going to produce in our economy those things that people want, even though we may have the capacity to produce beyond that point. And so then those that are represented on the curve are the maximum outputs of both of those goods given the resources and technology that we have available to us. So it is possible for us to use every single resource that we have to only produce product A. If we did that, we would not be able to produce any product B whatsoever because all of our resources are being used to make product A. Same thing going over here. This is a possibility. And be careful because this is a test question. Even though I don't have points here, we could make points starting here and at every single place on this particular curve. Even though it's not there, these are the possibilities. Anywhere, starting with making all B and no A, making all A and no B, and then any combination in between. And what we're going to be looking at is in order to produce more of B, we have to give up some of A. We cannot make them both. So what is the opportunity cost? When we increase production here, how much are we giving up of this one? So that evaluates the opportunity cost. This shows if we do have some sort of increase in resources or advances in technology. If this is our original production possibility curve, E would have been impossible because we're using all of our resources. A, B, and C would be possible. D is possible also. We're underutilizing our resources. We're not being efficient because of demand. But if we were able to find some sort of new technology or some new source of natural resources, human resources, capital resources, whatever it was, and that those could be used in both the capital goods, so we can make equipment, or consumer goods, those things we use for consumption, we could actually shift the whole entire curve out, and we have a brand new curve. In this, E is using all of our resources at their most efficient level. A, B, C, and D are actually now inside the curve, so we're underutilizing, and we will once again do that because that would be the demand. And then outside the curve now would be an impossibility. This is showing what would happen if we had an increase in resources and technology just in one sector. Once again, we're looking at capital goods and consumer goods. Capital goods, don't forget, those are your tools and your machines and different things that we use to produce other products. Consumer goods are going to be those things that are made using these that we actually purchase for our own consumption. And so we could have an increase in technology or resources in the capital goods market without actually having that affect or do anything for the consumer goods. So this point is going to stay the same, but we're going to see a shift out here. And so once again, if this was our original curve, D, B, A, and H would have been impossible, but now that we've shifted the curve, H is the only one that's impossible, and then these are all underutilizing. If we have a loss of resources or technology, we would actually see the curve shift inward, and we typically don't see this covering all industries unless we have a loss of resources because of war. If we have a war here and it's devastated because it kills some of our natural resources, it blows up our plants, tears up some of our capital, and then obviously the loss of human life. Natural disasters would do the same thing. And then if we had widespread disease, some sort of plague or AIDS that would affect a huge section of our economy, then we would actually see the production possibility, because if we have fewer natural resources, fewer human resources, fewer capital resources, obviously we're not going to be able to produce as much in that economy. So we need to be aware of the differences in what these production possibility curves actually look like. If you'll notice, this one is a straight line, and you'll notice this one bows out, and that's the difference between a constant opportunity cost and an increasing opportunity cost. What a constant opportunity cost says is, for every one that I gain, well, let's go down here. When we go from 0 to 1, I give up 1, because that's the difference between 9 and 8. To gain 1 down here, I have to give up 1. Well, to gain 1 additional 1, 1 to 2 is additional of 1, I'm going from 8 to 7. I'm giving up, for every 1 I gain, I'm giving up the same exact number. It's 1 each time. For every 1 I gain, I give up 1. This is typically not the case. This would be, an example of this would be like in an automobile plant. Cars and trucks, because they're very similar, you would probably see a constant opportunity cost. We go from, if we make 1 less car, or if we want to make 1 more car, we make 1 fewer truck, because they are very, very similar. Most opportunity costs are what we call increasing opportunity cost. Let's go from 2 to 3 here. So if we are producing 2 units, we're able to produce 250 units here. And then when we go to 3 units, we only can produce 240. The opportunity cost is the difference between those. What am I giving up? I'm giving up 10 units. Well, here I'm gaining 1 more. So I'm still only gaining 1, but if I go up here, Now I can only produce 220 units. So by adding that one additional unit, instead of giving up 10 units here, I'm actually giving up 20 units here. So the opportunity cost of this fourth unit is actually 20. And when I go from 4 to 5, once again, I'm just gaining 1. So I'm going up here, I'm going from 220 to 180. That's a difference of 40. So what we're seeing here, as illustrated by the curve that bows out, is an increasing opportunity cost. For every one that I gain, the amount that I give up, I gained 1, I had to give up 10. I gained 1 additional one, I had to give up 20. I gained another one, I had to give up 40. I gained another one, I had to give up 80. And to gain one more, I actually have to give up 100. So this is where you're seeing that not all resources are exactly the same. So let's say we're looking at the production possibility of pizza and cars. Obviously, in order to make more cars, you're going to have to give up a lot more pizzas than just one. So you're going to definitely see an increasing opportunity cost because not all resources are equal. This one right here, make sure you know that the increasing opportunity cost is the more common. It is usually not a 1-for-1. It usually is increasing the amount that you have to give up.